Welcome back to our third and final example of this lesson with matrices and systems of linear equations. So the last two examples were, well, take that back. The first example, we dealt with a systems of equations that gave us a particular solution, so only one solution. Our last example, the second example that we did, we got a solution that pretty much represents infinite many solutions, because if you remember, we had the x naught plus some constant t, which t can be any number, multiplied by a column vector. And that t can be arbitrary any number in the number line, or any real number, and it will make the system true. Because if you remember that the kernel is just basically a vector that makes the matrix A equal to 0. And so now we're going to talk about a third case. Not a special case, but it's something, it's a specific case that, I mean, we don't get often, mostly because it's really easy to do. And that will be when we have a system that has no solutions. So how do we know we have no solutions? Well, we're going to figure that out in this example. So we have this system of equations. So it is three unknowns. Three unknowns with three, what do you call it, equations. So we have our x1, x2, and x3. And then our three equations. And so right off the bat, you can't really tell that this is going to give us no solutions, but we're going to see that it does. And so, as always, we gotta put this into an augmented matrix, find our matrix A and B to begin with. So matrix A would be 1, 3, 2, 0, 1, 3, 1, 3, 2. And then our B matrix would just be 3, 11, 14. And then our X is just going to be X1, X2, X3. So now we're going to put A and B into an augmented matrix. And so as we done before, put matrix A on one side, left side, and then matrix B on the right side. And then we just begin doing our row reduced echelon form. So what we could do now is subtract. We could subtract row 2 by 3 times row 1. And so that would give us a new matrix. 1, 0, 1. Bottom becomes 2, 3, 2. And so we'll have 3 minus 3, which is 0. On the right side, or on the column 3, would be 3 minus 3, another 0. And then 1 minus 0 is just 1. And then here we'll have 11 minus 3 times 3, which is 9. And that would be 11 minus 9, so that would be 2. So yeah, sweet. We already have the second row where we just have 1, 1, 1. And it's in the middle, which is even better. So that's cool. So now let's get rid of the the third row from the first column. So what we're gonna do is take row 3 subtracted by twice row 1, and we get a new row 3. So we end up getting 1, 0, 1, 0, 1, 0, and then 3, 2 on the right side. And then so 2 minus 2 is just 0, and then 3 minus 0 is just 3, and then 2 minus 2 is 2, and then we have 14 minus 2 times 3, which is 6, so it'll be 14 minus 6, and that'll be 8. Alright, cool. This is supposed to be a 0, my bad. Alright, cool. So what we can do now is subtract. So okay, before we do that, we can, I don't know, like some of us may already see it, but we can see something interesting happening between row 2 and row 3. And so what we're going to do is we're going to take row 3 and then subtract it by 3 times row 2. And so that will give us 1 0 1 0 1 0, and then 3 2 on the side, 0 0 0. 8 minus 2 times 3 is 6, which is 2. And this gives us something interesting. So this is our row reduced echelon form. We can see here where we have 1 1 here, but we can't eliminate it. However, in the bottom row, third row, we can see that we have 0 0 and then 2. So we would have put this back into our like regular system of equations. We will get x1 plus x, actually let me space these out, plus x3 is equal to 3. Then we have x2 is equal to 2. And then here we have 0 is equal to 2. And we know that's not really true. 0 is definitely not equal to 2. And so this is where we can conclude that this system has no solutions. And yeah, that's pretty much it for this example. It was a quick one, it was a simple one, but it was another type of solutions that we were able to get. And that covers all of systems of equations, because if you remember in your regular algebra class, there was only 3 cases where you get one solution, infinitely many solutions, or no solutions at all. And we already did that in these 3 examples, with being no solutions being the last one that we did. And so yeah, that was it for this section of linear algebra. Next lesson will be inverse matrices as well as determinants. They might be in one video, they might not, I'm not really sure, but we'll see how long it takes me to do it. So yeah, I'll see you guys in the next video. Bye!